Okay. Hello all. Welcome to SP System Design session. Today we are going to do a deep dive topic where Sonia is going to present on MongoDB. So with this, let me hand it over to Sonia.
Hi guys. Good morning and good evening in Indian people. And so now today we'll be getting some ideas on NoSQL database, and one of the NoSQL database, which is document-based database. And I can share my screen. Let me share my screen for that. Also, I would like to say that this is just a session, and I am just new for this one of the system design session, and I would like everyone should be jump in, and it would be in like an open discussion, and everyone is open to discuss on any other points and who have knowledge about this things more. So we would love to elaborate on this topic again. So thank you so much. Like so everyone is know about the SQL and NoSQL and why we are in the NoSQL field. So first of all, I would like to discuss some scenarios like why where we are stuck in requirement business gathering in business studies. For example, like in retail business, we have to manage large product catalog and how to interact with different store inventories and customer shopping carts. And there should be a huge amount of data. And so to offer, and sometimes to offer recommendations such as customers also bought. So this, we can see that this is a mass volumes of data that which is required to be processed very fast. And also it is obviously very complex in traditional database manner. So basically, because it's have a hierarchical based data. For example, we have uh, different, we have a different users, and users have multiple with different kind of data. So how we can relate? For example, I can say here that we have users, and users have first name, last name, their addresses. So in 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 traditional relational databases, it would be like first of all, yeah, user ID. We do create a tables, for example, user ID and their, and on the basis of their, for example, addresses and user ID, their different it can be like their products which they bought, anything it can be. So this will be a different tables. So, and but if we need information of these users, it would be very complex to do to join the we need to do join operations to do to gather information of that particular user. So this way, and definitely these are very genuine cases which we know. And here are some which we can see there are challenges. Like we have 1 billion consumers who buy its products each week and to engage with customers. And these are the complexities are data velocity, and which will prevent retail from effectively managing its global supply chain. And so traditional Rdbms systems are lack this flexibility, and we need some kind of a that database which handles these huge database systems, and which would easily be scalable as well. So here comes just hold on, we need to clear this. Yeah. So there are some differences of Rdbms and NoSQL, where we have heard so many times that relation database are very less equipped to handle largely data volumes, and while NoSQL are very flexible and scalable. Also relational DBs are mostly are schema defined. Like we need to define the schema before working on it, and but NoSQL is like it's just a fly on. Like it can be a dynamic. It is just a dynamic schema. We can create our fields on the fly for this NoSQL databases. And yes, it's expensive. RDBMS are expensive, and it's time consuming, but NoSQLs are very easier to update as requirement changes. So because in the RDBMS, we need to first of all create a new field in the database, and then need to update on it, make an ID update. But there is no such thing in NoSQL. We can easily add new parameters or delete a parameter in NoSQLs. And also relational database are table based, but yeah, NoSQLs we have document based, graph based, key values, and white column. There are different kind of NoSQL databases which we have, and all are there for their purposes, which will solve their purpose. Like document will solve one purpose, and key value will solve one purpose. So every NoSQL database will solve some purpose of the problem. And most importantly, yes, relational database are vertically scalable, which is very expensive, but NoSQL is very cheaper because we can scale it horizontally and in very cheap manner. Anyone can jump on this and can discuss their points.
Yeah, I have a question. So why do we say that relational databases are not scalable? We can shard the data in a relational database as well, right? And then distribute it among multiple nodes. So let's say a simple example, let's say I have A to Z 1 million customer. I can say that users with A to F are in one node, in one database node of relational database, and then F to H. Or I can do some like hash-based partitioning, but I can use those strategies to distribute the data.
But is it something like that's something I have to manage myself and have to make sure like everything works fine? But in case of these NoSQL database, the software itself handles the partitions and other things.
Yeah, but like, however, this NoSQL would be distributing same thing, and I believe this relational database uh, uh, service providers could also implement this in-house and then give you this functionality for free, right?
So I think the problem
RDBMS database provides the functionality of partitioning based on the key. Like most common use case are where the created date is the one of the most common use case. Mostly like in from like my past experience, something like transactions of let's say transaction in the stock exchange, something like that. So ideally it is possible, but I think one challenge where RDBMS bottlenecks is a write intensive operations.
So I think the problem is with the relations. Your data is in different tables. Let's say you shard your data of your person on A to M, and then you have address table which could be sharded in some other way, and then this data is partially living in some other shards, and when you're trying to run a join, then the problem will start coming.
Yeah, it will be very complex to
Cross-join will
do
be a
these kind of.
But then my question is like maybe Sonia will answer later on like how cross joins are solved in NoSQL.
So I think NoSQL, the idea is like it's a denormalized kind of database where your data is already together in one document or in one thing, and we don't care a lot of things about joins or transactions. If
But,
you see,
yeah, no, that's right, and probably that's what this node relation. But in my mind, I always keep on thinking that then the same thing you can do with relational database also. You can like denormalize it. You can keep the similar data in one node, like all the related information for those customer, their addresses table and all those you can keep in one node so that you
Yes,
don't.
so it would be similar like for document DB will be like similar like with relational, which is which is not normalized then. So,
But
but
There is no schema, right? If you keep
yeah, but
everything,
there
whatever
will
you
be
want to add,
that's the point. Yeah.
the
if
schema
you
is
want,
one, and other thing is, this my my personal observation. Like these relational databases, like never being designed in that way to be denormalized. They're always designed to be normalized, and then we are this will be anti-pattern for relational databases to make them denormalized, although they are designed for like a kind of a normalized way.
yeah, but then that's why they call it relational, right? There is a relation between tables. If you denormalize and put everything in one place, then there is no relation. Like it's in all in one place.
And they designed in different ways. Like if you see, they designed like they store data in row based thing. Like if you see new databases, they are like column oriented. Like there are different things, and that's I think again design decision based on your requirements. If you want a lot of filtering, or you are looking less transactions, eventual consistency is kind of fine, then go with these NoSQL approaches. If
Yeah,
the tougher constraints, then yeah, relational database is a good choice.
Yeah,
But I
yeah.
think,
Somebody said,
so
go ahead,
I
go
think,
ahead.
but yeah, I think one of the main aspects is that the ability for these databases to be sharded is the key thing, right? Because that is where you eventually get the scale. So
Mm-hmm.
with the relational databases, traditionally you would have the whole system that is running on a single machine, and you try to scale the machine vertically, however much you can get, and you run it to a limit.
Why
Yeah, but
can't we shard NoSQL databases as well?
I think,
What's stopping from sharding NoSQL database?
I
We
think it
can.
does good.
NoSQL database, I think by default are started, I guess.
Yeah,
Yeah.
we can start it. Yes.
but when creating a NoSQL, I think you need to mention how many nodes you are looking, how many shards you are looking, what will be your partition key, and
And
other.
what would be a shard key? Yes, definitely a
The
partition key.
main issue I see with the NoSQL is transaction constraints. Say I'm a payment provider. I am not okay with using a NoSQL. There is no transactional guarantees. It's an eventual, like if it fails, it fails. That's kind of the consistency that I'm getting with NoSQL. If I want a really consistent and really like for payments related applications, I'm probably not going to go with NoSQL. That's
Yeah.
probably a question on your application.
Right. It
Yeah.
basically just depends on the requirements, right? If you really want consistency, like a very traditional application where you have a banking system, and you have to move balance from one system to the other, right? One account to the other. So in this situation, you definitely want to prefer something relational which can support transactionality.
Yeah,
Yes.
transactional
I
consistency is
would
what
like
I
to
meant.
add one observation. Maybe one thing which I have observed so far is if you see where Rdbms started and NoSQL started, they were two different, like totally different in characteristics. But as of today or going in future, they are also started overlapping their possibilities. Like earlier when we were discussing about denormalize, so at least in like few years back, Rdbms was not able to build an index or do lookup inside a field which has a composite JSON or something like structure, a complete document as a stored in a field as a string. But
Like
I think these days they can do that, and which NoSQL by default did that.
yeah.
for example, Postgres is a relational database, but Postgres can store fields in JSON, and that is indexable also inside a Postgres
I think it's
column.
a column-oriented database.
I think most of the databases now can store this, they call it hybrid schema. So
Yeah,
almost every relational can store a JSON and index it, and they have specialized functions for it.
Yeah, so no,
Like
it's like MongoDB's document is divided in the JSON structure, I guess.
Yeah. Let's move on.
Those-
Yeah. So yeah, today here our mostly discussion will be on the document database and one of the document database, which is of MongoDB. So as discussed now that we have a document database, which is a type of a non-relational and is designed to store and query data as JSON-like documents. So we have, and so let me open my notepad over here. Yeah. So can you see my OneNote over here?
Yeah, we can see.
Yeah. So like how a Mongo document DB basically, which I'll be calling a MongoDB store here. For example, we have a database, and in that database we have collection. And in one collection we have different documents, document 1, document 2, and these documents will be in a JSON format. Let's take one example. So for example, we have, let's say, we define one database, which is your company's, any company's database, any database name you can take. And in that database, we have collection. For example, I want to have a users. So all the data which is related to, and in that user, this is a collection name, and we have, and I can add one document over there, and that document would have first name, last name, anything like their value, their addresses, and this can be in a array format as well. Like there can be multiple address of one person. So like these are all fields, and this is one JSON format for, and this document, there can be more fields, and this is one document which stored in this user collection, and this whole document is a part of your data. And so this is one of the functionality which MongoDB helps. And one more thing is like when you save and when you do any insert operations, this would automatically create an ID field, which is auto-generated by MongoDB, and it would create this ID which would be unique for all those documents. And how this will help you, how this will help us. So main point is, for example, if I have some my applications which I have some data transfer objects, and I have some user, and these fields are, these first name, last name, addresses will totally map with my my data models. Like I have some data models, and in that data models, this will be completely mapped, and it will directly store this. And if I declare this as a save in a user's collection, then it will directly save this as a field, this fields in this document containing these fields name and with value. So and as well as if you have some list type objects or any list categories or integer fields, it would also save as it is. So it will not, as well as Boolean, as a JSON formats take these data types. So this is one of the I would say cool thing which help us to create a new document directly and save it if we are just concerning for just one like one document with multiple fields in it. So this would be like one collection, and all those documents in that field. Any points anyone who wants to make in this? So yeah, this is one thing, like it's make easier for developers to store and query data in database by using the same document model format they use they use in the application code, as discussed now. And also this is flexible, semi-structured, and hierarchical nature of documents, and documents allow them to evolve with application needs. So we can create new fields on the fly. For example, we have created some documents which with some fields, and later on we decide, oh, we need some fields as like phone numbers or something and some additional fields, then we don't need to recreate the database like in Rdbms to add that field. We can just directly add the new document with that field. Yeah, but we need to add that document in our data model. We need to add that field, so we can add that in a database. But that's just one thing.
I think just one other thing from a terminology perspective, I think we call this as a schema on read, right, as opposed to schema on write, because you're not defining the schema upfront. And when you read the data back, which is nothing but a JSON, now you interpret it as what you want it to be, which possibly can map to your domain objects as is. So there's a very common terminology like schema on read versus schema on write.
Yes, thank you so much. And so this is schema read. Okay.
Yes, schema on read. Like when you read it,
Schema
you
on.
interpret it, and then you take what that means.
Okay, nice. So yeah, so how MongoDB is also one kind of a document-oriented NoSQL database, and which is used for high-volume storage. So as discussed, as in traditional relation database, we have tables and rows, but MongoDB, we have collections and documents. Here, each document you can think like that it's a row in our database. For example, in our Rdbms, we have rows, and each row would be act as our new field or information, new data. So here, similarly, in MongoDB, we have collections. Let's say this is collection, which is one table, or we can say, and we have documents. So each document 1, document 2, would be act as a row. Like just to relate these database, yeah, but there is a different structure, schema, everything. But to relate this, like how we store new information in the row for Rdbms, we have documents can act as act like a new information or a new data to store in our database or in a collection.
So you're saying the records which we are in a Rdbms, it will be a document in a NoSQL, right? In this document. Okay.
Yes. So I want to say like record, like I said, new information. Yeah, it should be a new record or new information of like how we store in a table as a row. It like MongoDB has a collection and documents, and each document will be act as like a new record.
Could we query by column name in MongoDB?
Yes, we can like here how we query on the basis of particular, let's say in a relational database, we query on the basis of that column name. Here we can query on the basis of, let's say I write over here only, like we have, yeah, let's go on the next screen only. Yeah, so for example, here we have name, age, status. We can query on the basis of this particular name. Like we need information on the basis of this. And name is like, obviously name is like a one particular field. Age is like one particular column. Sorry, I need to say column. And see, all these are having their information. So we can retrieve if we are filtering out on the basis of one particular field, as we are filtering out on the basis of the column when we are querying. The main point is like here we have arrays and arrays of documents as well. So if we have this, we can have. So here we can have multiple documents, as inside the documents we have name, age, status. We can have, let's say, example of address only, address, and this is itself a new an array which can have multiple fields. Sorry, this should be like this, like multiple information in that can be nested. It feels like it's a nested information, and you can query this, and inside this you can query nested as well. Nesting query can be happen as well over here. And other thing is like, if you want to store this, this was one thing which I meant to mention, that this has nested things and nested queries can be happen. So is that answer your question?
Yes. So I can query like get out the name.
Yeah, syntaxes can be a little bit different over here. Like here we use find, like for to find any particular, like to field, to retrieve the data on the basis of that particular field. Like in find, we use, like here insert is doing, we are using users.find, and in that find operation you can specify, for example, age is 26. So you will be able to retrieve the data on the basis of documents where age is 26. So you will be getting the documents. You'll not be getting any one particular only age. So that can also happen where you need to find that just show me these fields. That would be also different queries are there. Like just like how we are in a Rdbms, we are like just select first name and last name from this table name. Here can also happen like users.find where we need to find only these. We only want these fields to be shown, and on the basis of this particular, where this is a where category, like where this age is equal to 26.
I think the other aspect of this one, if I'm not mistaken, is like, yeah, you can do anything you want in terms of where clauses, which is just like a where clause in a SQL, but you have to make sure that you create an index in MongoDB infrastructure based on those clauses in your where clauses. Otherwise, the performance will be pretty bad.
Yeah, so that's another, like we'll be moving on with the indexing as well. So how indexing will help here, and one of the plus point of a document database or MongoDB, I would say, is indexing. We'll discuss in our next upcoming slides.
Sure.
So yeah, as we are saying that we can query this thing, and documents correspond to the native data types in many programming language. As I discussed, like it's also like only we have string, integer, boolean, all those arrays, lists type. And so how we create an object over, so for example, I have in my data structure, I have created an object, for example, any object which would be like let's say the users example only. I have created a users, and it's a nested database that I have, and I have inside the users, I have some fields inside it, which is, as discussed, age, status, and addresses, list of addresses. So this is one, I think I would say object. So how one object we behave in while creating our data structure in our, when we are actually implementing these. So this is the thing, like documents as objects. And as discussed, it's embedded documents, array, reduce, and arrays are there which reduce for expensive joins. Let's move on to the next slide. I have to. As discussed, MongoDB stores documents in collection, and it's similar to the tables in relational databases. And so how it MongoDB provides high performance data persistence support for embedded data models. It reduces input-output activity on database system because we are creating the exact data models as are in our database. We have created a fields. And so yeah, first, as we are moving forward, we know that in indexes is a support faster queries, and plus pointers indexes over in the MongoDB, which help us to support faster queries and can include keys from embedded documents and arrays. And how we are doing, let's skip this. So yeah, first of all here, MongoDB, sorry. So MongoDB, first of all, the features, as we discussed, it's documents. Each database contain collection, which contain documents, and it has a structure as developer construct their classes and objects in their programming languages. It's similar to the DAT structure. And also each documents will act, each row or documents is called a MongoDB, and we can create a new fields in Fly. And the data model within MongoDB allow you to represent hierarchical relationships, as I discussed, to store arrays and other more complex data structure, in which would be more easily we can create those. Why use MongoDB? So it is document oriented. It is indexing. Indexes can be created to improve the performance of searches with MongoDB. It can be easily replication, and it support ad hoc queries, and load balancing can also be used concept of sharding to scale horizontally. So why ad hoc queries? As MongoDB supports searching by field, range queries, and regular expressions. So as I started this session with the example of we are running a retail business, and we have lot of data of one particular users, like one particular user with like how to improve the recommendation system and store massive data for their behavior. So all these things, and we want information on that particular user. So how that would help? So query is one of the most important thing to get information on the base for that particular user, and to improve our system. So one of the plus point for MongoDB is that it will be like we have the queries which are very easily be done. Why it should be easily done? Because of this indexing. So we should move ahead. Yeah, this is a use case which I have written, that if we have data retrieval, why we are requiring this kind of a database system, because if you see very heavy query usage, then consider the use of indexes in your data model to improve the efficiency. So if you have indexes has been done on your database, then the retrieval would be very easily can be done. Similarly, if you have inserts and updates and removals very frequently in the database, so we need to reconsider the use of indexing, and which would incorporate the sharding if required in the data model to improve the efficiency. So yeah, indexing. So index in MongoDB is a special data structure which hold few fields of documents. For example, this is one example of how we can create index. So if I say I have a user ID, and I want my I need to create index on the basis of user ID. And one most important thing is, like, if you know your query criteria, that your application would hit with that particular query a lot, we can create the index of that particular query, and that would be very easily we can retrieve. So here 1 or -1 would means that it would create an index of that particular field. 1 means in ascending way, and -1 means in a descending way. So it would automatically create index of this particular field in an ascending or descending way. So this would improve the speed of search operations in the database, because we are not searching the whole document, but we are searching this on the basis of indexing.
Sorry, just quick question. Is there any significance when we say it's ascending versus descending?
That's yeah. For example, if I want to query on the basis of age, and I want
because the reason I'm thinking, like, like, for example, behind the scenes, if you implement some sort of binary search, knowing that this data is sorted, then normally it would not make a difference when it's ascending or descending, but there must be some other explanation.
For one single field, it doesn't matter, I would say. Like if you are making an index for one field, there is one more concept here is a compound indexes. What do you mean by compound index? Where you can have the criteria, for example, user ID and age. And if you are, if we are making an index combination of user ID and the index, we can specify if I want user ID as 1 and age -1. So what this would mean that it would index, and this is based on completely your requirements. So this would make your index user ID on the basis of ascending and age on the basis of descending. So if someone search on the basis of this, so it would get documents on the basis of this search criteria if they are required. Like we need a higher age people, and specifically, actually, we don't use user ID as like for our search criteria because nobody knows. We definitely know the first name. Oh yeah, user ID can be also done. Like user ID can also be done. Yes,
yeah,
any field. Sorry, any field can be added, and so this would help us to identify the if you require in the field of descending. In compound indexes, yes, it would help us. In single, I don't think so. It would hardly matters if you are making ascending or descending.
Sure.
Yes, and anyone can make it more clear if they have more information about that. So yeah, so this is one thing, and about the compound indexes, which is helpful in creating your indexing. Yeah, so here has it mentioned that too many indexing can hamper the performance of insert operation. For example, I have all the fields, and I want every field to be indexed because I don't know, maybe my my application would can search. I want open to search anything on my documents. Then it would obviously hamper your insert or update or delete operation because it has to, first of all, whenever we do write to our for example to our database, and we are inserting something, it has to index all the fields, and the write operation will be very heavy. And also if there would be some partitions also have is there, some replicas are also there, so it will also slow down the whole process if you have too many indexes out there.
Are we going to talk about partitioning as well, like making partition keys?
Yes, we are going ahead. Yes.
Sure. Okay.
Yeah.
No, because that use case becomes, I mean, I don't know much, but I think the use case becomes interesting when you have some field which is a partition, but you still want to index it, right? So the indexing still could be local to that server instance shard, but then you still have to go across the partition to get data, right? If you want to combine something beyond what's in the one shard, right?
I didn't get your point. Can you elaborate?
Because sorry, no worries. What happens basically partitioning wise, right? I would think partitioning just means like the fact like you're dividing your data. Let's say you are dividing your documents across more than one server, right? So depending on whatever your partition size is, let's say 3, then you are dividing all your data in 3 different sets, let's say shards.
Yes.
And then let's say I want to be able to say, get me all the users. So it has to kind of go across all the different shards get how many documents there are in one, plus second and third, and return it back. And now let's say if you want to search something within the users, then of course it will try to search within the very first shard using an index to filter it out. Then I would think it will kind of go to second shard using the index, which is local to the shard itself, filter that out, and so on with the third one, combine all the results and return you back.
Yeah, that would be very depth. I would
No,
say.
that's fine. I'm just
yeah. So we be touch base. We'll be we are touch basing on that, so we can elaborate over there in that topic. Thank you. Yeah. So yeah. So as we were discussing that there would be a default ID index where MongoDB creates a unique ID during the creation of collection. So for example, I make a command to save my document. I'll not be adding this ID field. This would automatically be added by MongoDB, and it will be adding on the basis of their whatever the timestamp, and I think on the basis of the shard which it is going. So I think that is one criteria where, if as far as I know, that would be MongoDB would create that ID field. Correct me if I'm wrong, because that's one thing which I have read. That, and so yeah, this ID index would and this ID only makes this as a key value. So this ID would be as your primary key, and the rest of the whole documents, like this ID would contain the values that would be your value for as a key value store. But we are not like saying that it's a key value. MongoDB is a key value, but as we are saying that if we are searching, so ID would automatically be, and your index, if you're searching your anything, it will be on the basis of this particular ID. So this is one, and clients like ID index prevents every client from inserting two documents in the same value. So for example, if I have two documents which is exactly same, so how it would differentiate the two documents? So the only differentiation would be this ID. That's one thing. So as we
so sorry, does it mean MongoDB generates this ID index ID based on the hash of the whole document? That way it basically rejects a secondary identical document to be inserted.
I wouldn't
no, I would not think so, right? Because you can have the duplicate documents. There's no problem with that. I mean, it's up to you to decide how your schema will look like in terms of data it contains. So end of the day, it's just going to generate a unique GUID, if you will, and that's not going to change. And that's kind of going as part of the index as well.
So if that's the case, that this, I mean, what makes me think that way is this sentence, that the underscore ID index prevents clients from inserting two documents with the same value for the underscore ID field. So which means, I mean, when the application insert is any like document, right? They don't provide an underscore ID field. It's rather generated by the MongoDB itself and returned as part of the insert, right? So in that case, like from you, there is no like really preventing user from inserting like same document or like a same content, correct?
Yes, I mean, that's what I would think, but we can definitely check on that sentence too. Maybe there's some other use case where, I mean, speculating, just there could be some other use case where you can turn something on and maybe does some hash check or, and then says, okay, I do something out there and prevents that. But otherwise, I mean, my experience with what I've done, I don't think we do this. As
okay.
an insert, what are
as far as I think, I'm not sure, but I've used DocumentDB, MongoDB, and I have able to insert two same documents, but that ID will be different with this generating.
Yep, that's what we in the capacity.
Yeah, this it's just that the sentence will confuse. That's why I got confused.
So what they specify over here is like inserting from two documents with the same value. Maybe the context is like ID index would differentiate if there are two same documents as well. So this would prevent them to, if the same values are also there, this would prevent them that these two are duplicate. These are not duplicated. Like ID would be ID of these two documents would also be different if they have the same value as well.
Okay, so you mean like there is no really duplication? It's always every insert guaranteed to be unique.
Every insert, yes, guaranteed to be unique on the basis of that particular ID.
Okay, got it. Thanks.
Yeah. Yeah, this is one thing. And yeah, so as discussed, we have a compound index is in our MongoDB, where single index structure holds reference to multiple fields within the collection documents. And while to create a compound index, this is a syntax for creating a compound index, and the order of the fields here listed in compound index is important. Like, yeah, order is very important. So what it will do, it will at the first, it would sort on the basis of first item field, and then within each item, it would sort by values on the basis of stock. So if you reverse this way, like it would sort the documents on the basis of stock first, and then on the basis of item. So the order of how you are creating a compound index is very important as well.
So in the compound index, which one is used for the partitioning, the sharding, and which one is for the sort? The first one is for the sharding.
So for sharding, you will be specifying your partition key while you are creating your collection only, I think. So it is not matter, like indexing and sharding are two different parameter. Yes, you can make your shard key as an index as well, but yes, these two are different. If you want to make this compound index as your shard key, then you have there is some criteria that you can make it a hash, and then like how shard key can be like happen, but shard key should be as such, like it should available in all your documents, and item and stock should be available in all the documents. That these are the required fields for your JSON data structure to be there. So if that, for example, we don't have one particular field in one particular field in your document, then that cannot be your shard key. So, and while making a compound indexes as well, you need to make sure that these two fields are there in your all your documents. And we can make, as part of your question, we can make them as a shard key, but so yeah, shard keys preferences are so much different that it should be every time unique, and if we have this item as a continuous, or item ID as a continuous, that should not be a case. But yeah, we can create the compound, and then we can make it a hash, and that can be your shard key.
Okay, so now, as you said, I think it makes sense to have the shard key as a part of database creation itself, and this is for basically creating other indexes within shards, I guess.
Yes.
Yeah, this whole index component index is more about locality.
Locality, right?
Yeah, within the shard, and then shard is kind of the high level concept which divides the data across multiple servers, if you will.
What is the use case of create compound index? When would I need to create compound index?
So if you have any so
I think one way to just look at this, right? So if you just try to think through from a SQL perspective, anytime you have anything in your where clause, right? You can say where name is this and age is that. Then if you have, let's say, 2 columns in your where clause, then very simply what you can say, I'm going to create a compound index, which is a combination of these two. If you have 3 columns that you're regularly searching for, then you can create a compound index with 3 columns. So, and if you're only searching with 1 column, then you just have 1 column as index. So that's just a very rough way of saying how and when I would create compound indexes. And of course, if you have, let's say, 10 columns that you're creating, and maybe that's not on a regular basis, but you have a compound key with only 3 columns, then it will try to use those compound key with 3 columns and still try to filter for you for 10, based on the 10 columns that you have.
Okay, so in this case, my search key will be, the first will be item, and then the second criteria would be stock. But what if I have another query, a search stock first and the item second? Do I have to create another index, compound index for that?
Yeah, I can just speak from just what it should be. Don't know how it works, but I would think like the MongoDB is smart enough to say that I understand that these are 2 different columns and how the indexes are laid out, so I can switch that thing around. So that doesn't make a difference in my mind. I should be able to say behind the scene implementation, oh, I know that item is first, but doesn't matter that's in the second in the where clause, like this is the second criteria. I can swap it around and then use it as if that was the first one and search based on the index that's out there.
Yeah, okay.
So I would say
it
probably
might not
the answer should not make a difference.
in programmatically, but yeah.
Because end of the day, some query optimizer, right? Some engine is actually executing your DSL into an actual lookup against the database where the data is stored in JSON as documents collections. So that optimizer, I'm sure, is smart enough to say, okay, I understand this. So let me kind of go in and try to use those indexes in the order in which they're defined, so as I can reach to the solution optimally, right? Like faster, as opposed to going the reverse way and it's going to take longer.
I think this in this NoSQL case, I think the ordering is important because I think the idea is that the first column item, right? You can have for one item, there can be multiple stocks, right? So and the way the database arranges is basically for all the rows with that have same item ID, and then and basically for that item there are multiple stocks. It sorts the stocks so that you can query for this item what are the stock values, and you can get like the range of stocks. And if you reverse, it will be other way around. Basically, one stock, there can be multiple items. So now it basically sorts the items for a given stock ID. So it's not exactly like where ID for SQL in that perspective. It's more of like, as you said earlier, right? Localizing data. It's basically one-to-many kind of relationship, and then sorting to query all that data for one item, the multiple values in one query.
Right, and I think it also uses this what we call the reverse document index kind of concept, right? Which is more like a hash map into where the mappings of these exist in terms of and the documents mapping, right? So they can quickly go through the documents itself.
Yeah, I think you could do it too, but then now you have to search on different area, by different places, versus you searching only one place.
So, but when you have indexes, then it's kind of using the index to derive what documents it needs to match, and then it kind of goes to documents and picks them up, right? I mean, that's the whole point of using index, that you have this so-called local configuration of what we call reverse document index, which is saying that for these combination of keys, or maybe there's some optimization where you have keys to ranges and stuff like that, then you can point to the different document IDs, which are the IDs we talked about earlier. And then you can say, okay, for this combination, what you're searching for, I can quickly give you the answer. And now I can go and fetch those documents, combine them, and return them with results.
Yeah, and quickly, I should be answering one of the Lion's question about the use case, and then we need to move forward as constraints of time. So, so one particular use case which I thought is like when, for example, there is a category type in a retail business. We have a category type and age. For example, there is a we are getting queries a lot about the kids in that particular age group. Then we need to retrieve the data for that particular. So in that particular scenario, this compound index is very helpful if we are if we know that our searches on our applications are basically most on the category type and the age. So it's better to create an index for these fields beforehand, so that it will help us to retrieval pattern would be very much quicker. On that note, we should move ahead. Yeah.
Hey, I have one question. These kind of range queries will result in entire table scan, right? Irrespective of the sharding that you have done. Because sharding could have happened on a user ID, but my range query is based on age or something else. Every shard could have the same range of age. So that means that results in the execution of this query in all the shards and then combining it in one place, in central place, and then returning the results. Is my assumption right?
Yeah, I mean, if the data is sharded, I would think yes. I mean, if the data is sharded, that means when the query runs, that set of data is not in one shard. It has to go across the shard to get it and filter and combine.
So that means sharding here is not helping such kind of an access pattern where I'm trying to use a different index, or even index is not helping me either here. Index may help locally in a particular shard, but as you look at the whole query, so you may end up executing this query in all the shards. Right? So
Yeah, yes. I mean, I could be wrong here, but that's what it seems like. And maybe with the concept of replicas, if you have the replica for the shard going on, and maybe the replica happens to be the other shard, then maybe it can do some optimization where it doesn't have to go across shard. You can pull it from its own local as well, because it has a replica for some other shard. But I'm not sure if that's going to be guaranteed. But definitely, if you're going cross shard, then it has to go across shard to get the data.
So yeah, does it mean that indexes may not help us there? The index is only specific for the point lookup query.
So it would be helpful, like in one particular shard indexing, like if we have already defined the index, and it would be it would be easy to retrieve on from one shard. That's where index can help. Like, but concatenating, or we can say aggregating the results from a different shard is one thing, where one manipulation could be happen, but retrieving a data from one particular shard on the basis of indexing can be is the faster way.
Yeah, absolutely, because the individual results will be optimal. So when you combine, you will still get an acceptable result.
Yes.
As opposed to if the individual result itself is bad, even if you combine, it's going to be exponentially worse.
Yeah.
Yeah, that makes sense. Yeah.
Yeah, that's where indexing can be helpful. But otherwise, if our query is like that it has to go to all the shards, then the only optimization we are helping over here is to make an indexes so that we can at least retrieve the data from one particular shard in a quicker manner, and then we can connect. Then we can concatenate. Oh, moving on, then we have this as in one example that this is a collection, this is a query criteria, and we can query on the basis of range based over here. For example, this indexing is one thing, and then there's another. This means that less than. If you like this is mean less than, scored less than 30. So it would retrieve the information. And score -1 means in descending way. So yeah, so it would be retrieving us less than 30 in a descending way. That's what it means over here. I think this is, yeah. So moving on, we have a replication in MongoDB. It's a we'll be creating a replica set in MongoDB, which is a group of MongoDB processes that maintain the same data set, as we know that replicas means. So it would provide redundancy and high availability and all the basis of for our deployments. So we know the definition why redundancy and data availability, like replication provides redundancy and increased data availability. with multiple copies of data on different database server, provides different level of fault tolerance against loss of any single database server, and also can provide increased read capacity as clients can read operation on different servers. Also, it maintains the copy of data in different data centers to increase the data locality. It will maintain the additional copies for dedicated purposes as disaster recovery and reporting or backup. So this is why we require the replication. So how replication in MongoDB happen is like it's a group of MongoDB instances that maintain the data sets. We have contains several data bearing nodes. One is it's obviously lead and follower. It follows the pattern of lead and follower pattern, where one is a primary and there are different some secondaries nodes are there, and the read and write operation would happen only at the primary level, while read is at the secondary levels. So we always have we'll moving ahead and we'll discuss why we need at least three nodes in one replica set. This whole is called a one replica set, and why we need at least three as nodes. So this secondaries replicate the primary node, and which would apply the operation of the data sets. So secondaries data set reflect the primary, as we know. So if the primary is unavailable, and so election would happen, and eligible secondary will hold an election to elect itself as the new primary. So this can be an arbitrary node as well. So if we can have one primary and one secondary and one arbitrary node over here. So this arbitrary node would mean that here instead of secondary, because secondary will hold the data as well. So here we can have the arbiter node, which would just be there for election purposes. So that's why we require three nodes. It would just happen, it would be there for election purposes to elect another primary. It will not have any kind of data or something to happen. So as discussed, the client can only write data to secondaries and can read data from the secondary members. So if secondary can become a primary if the current primary is unavailable, the replica set holds an election to choose one of the secondary becomes a new primary. So election would happen, and election could be on the basis of who is the quicker and whose priority is more. So there would be a priority as well. And if there was priority, for example, this particular secondary has priority 1 and this particular secondary has priority 0, so this automatically becomes a primary if this is not there. And there is a heartbeat how when we say that this we need a new primary, because it's there would be heartbeats which set we can say that it would ping each other nodes in our replica set, and if no one replies within 10 seconds, then other members mark the that particular member as inaccessible. So that's one thing where we moved ahead, I think. That's why we need like timeout if we don't need that. If we lose some connectivity with that primary, then we want we can set this time as 10 seconds or any seconds which we want. And if it doesn't reply back in that manner, then we need to when we need to make an election policy, that election would happen and we need to choose primary over that at that time. So one thing is that replica set cannot process write operation until the election completely successful, because it doesn't we should not make any write operation when there is no primary yet there. So until unless that operation is successful, election, and we got one primary, then we can make a write operation. And to make that time for the election of new primary and make all other as other make nodes as secondary, mark other as secondary, and also mark the primary as unavailable. So we should not exceed 12 seconds. Here, what they mentioned, that median time should be 12 seconds. It's up to you, I think, what time you required. So this is ideally the time that everything should happen, so that we can easily, after the election happen, we can make up one primary and other secondaries, and then we can move ahead with write operations.
Just one quick question. I mean, do we know, like, if that is happening, will the API request to actually make write operations fail, or will they just be in a limbo waiting state?
Yeah, that's a good question. So maybe it would be on a hold, or
Yeah, because it can be done, it can be implemented however, right? Of course, this
yeah,
is we hold on to request till it makes an election and then lets you write that, or it can be a fail fast where you can just simply say, you know what, we are not available, basically. So
yes, yeah. So that's how not available is, I don't know what request we responses, I don't know, 400 or 500 in server is not ready. That kind of a process.
The reason I'm saying so, because end of these systems are supposed to be highly available, and then maybe by reducing the time for the selection, you kind of avoid a little bit longer outages. Or I mean, depends upon if somebody says 12 seconds a big outage, it is a big outage in a way.
Yes.
Especially when we say something is highly available. So.
Yeah, that's the point. Yeah, we can, yeah, that time limit we can make it on our cases, like what time limit we require for that. But yeah, so talking about the processes of what would happen when this operation is going on, when some write would happen, that so read can be done. So only the write operation would be hampered. Only read can be helped, because cannot be hampered, because read can read from the secondaries unless primary is ready. So read can be done. Only the write operation is, we need to make sure that this time should not be as long, because it would hamper the application and the availability constraint. So
I think because it takes some time to fail over, right? This is
yeah.
so essentially it's trying to fail over to some other shard to become a primary. So I think that this is going to be the case no matter any system which has this primary, right? As opposed to Cassandra or somebody which is like a masterless system. This is a master system.
Yeah, master slave. Yeah. Okay, so I have one question coming over here in my mind, that if we have, so if this is busy, if primary is busy over here, is there any way we can make other, we can switch our request to other shard? If that shard we are not getting any response from one shard because of this election things are happening, we don't have any primary. Is that possible that request can move ahead?
Yes. So I think it's not the shard here. This is there are two levels. The sharding is to distribute data among multiple shards, right? These replicas are the replicas of a same shard, right? So for the same, let's say if you go into shard, right? You have like 3 replicas, one primary, 2 backup for the same shard, right? So in this case, typically in master follower kind of architectures, generally all the writes, if you want to have constant writes, all the writes typically go to master. You don't send writes to, and even if you go back to the picture you showed in earlier, right? All the writes to go to the master. Only reads you can actually get from followers. So that's how the system is designed to provide kind of a linearizable writes. So all the writes have to go to primary. The system doesn't send, it can't send to secondaries, all the writes.
Yeah, but my point was, like, for example, this is a client driver and I am So my request is going to this particular replica set, I would say, and for write operation. So if this, I am not getting any response from this primary because of that election is happening, then can it go to the second replica set for write operation?
No. The way again the way you should design here, it seems all the writes have to go to primary.
Yeah.
If your election is ongoing, that's why the 12-second time we talked about, right? During the time, basically writes are blocked. I mean, you can't, writes won't work.
Yes.
During and if it takes more, then you are unavailable for that duration of time.
So this is one of the constraints of master-slave policies, master-slave pattern, we would say.
Yeah. So this is basically, looks like the system is designed for very high read throughput. Because read and it seems like even this read also is tunable. You can even set and reads whether if you want a linearizable reads, that's a constant reads. The client can decide, say, I want to read only from the primary, but the client applicant can specify if they want highly available reads, any data is fine for them. Then they can just say, okay, my preference is to read from a secondary. So it seems like in the write is always the primary, but reads are kind of tunable from the application perspective based on their consistency needs. Looks like that's
So if because our application is our application and it's our if we want make our application only as a read heavy, that which is more which make it more available, then this design pattern is helpful in that. Yeah.
Exactly. That's our design. Yeah,
makes sense. So this is a heartbeat, as it would check if heartbeat doesn't return within 10 seconds and it's inaccessible, and how we make a member priority. So after replica set has a stable primary, the election will make a best effort to attempt to have a secondary with the highest priority. So the highest priority will be the one which would make a primary, would have the more chances of becoming a primary, because as we see, this is their votes are 0, which means that their priority is 0. So there would be no chances of becoming these two as a primary. So because this primary priority value is 0, and it will not be as a part of election as well. Do not seek election. Although known voting members do not vote in election, these hold the copies of replica sets and can accept read operation from client. Yes. So this is, I think this can become one replica set over here.
What is the purpose of having the secondary and it's not involved in the, it never become a primary, or it never, involved in any election?
But it would have the data, as mentioned over here, that it would have the copies of replica set data and can accept read operation. The read operations can happen from these, but it will not take part in a voting as a to hold the voting in to make who is the primary.
Yeah, but we don't need it. We might not need it, right? But why it here? But it's here for a purpose.
It's here for purpose for read operations. Like if any read operation is if there is any query is coming to read the data, it can go to these nodes.
So, sorry, one question quickly. So who decides that this secondary member may not participate in voting? Is that configurable value or something?
I think it's configurable, yes.
Right. So yeah, so that could explain, right? Of course, for example, if you take a general voting that happens, for election, some people don't vote, right? That's essentially, but they're still part of the system. They can.
So the way I understand it, basically there are two concerns when we design system like this. So one thing is fault tolerance, meaning when you design such system, how many, what is your criteria? How many node failures you want designing to withstand, right? So let's say if I have in a distributed system, if you have 2 F+1 nodes, F nodes can go down, it can still be available, right? So meaning like if you have 3 nodes, you can tolerate 1 node failure. So if you want to have highly available, it means you need to have more nodes as part of this, lead election process cluster to provide more tolerance, fault tolerance, right? So that's one concern. But if you increase this number of nodes in the election process, even though you provide very high fault tolerance, what will happen is it will increase your, your convergence, the redirection convergence time. So meaning during the time, the time it takes to elect a leader will take more. During the time will not be available, right? So it become unavailable. So that's why you can't arbitrarily increase the number of nodes part of the election process. So that's why. But at the same time, by having more nodes in the cluster, right, replication, you can increase the read throughput, right? So by having more nodes replication, but having only some of them part of election process, you are optimizing for both. You are reducing time it takes to elect a leader, but also having more nodes to provide more read throughput. So I think this way designed like that to optimize both. If you have all the replications to be part of the election process, then the election process itself will take more time, and you'll not be available during that time. I think that's why it's kind of designed that way.
And it's one more point is that I think it's configurable. Like if right. in further time, if we want these secondaries to also be as a part of election process, we can configure that again. We can reconfigure them, I think.
I think these folks, like the secondaries who can part of election process, could be strategically chosen, right? It could be chosen based on some criteria.
So the way if it's a multi-data center architecture, what they do is you have, let's say, for each data center, the 3 replicas, let's say. And I think some system I've seen, there are 3 replicas in each data center. Let's say 3 data centers, right? So what you do is from each data center, you'll have at least one to be part of the overall election process, but other replicas you don't have to be like part of the election process. They're just there to provide, the high read throughput for that specific data center. So you can choose like that.
Yeah, and then that also helps with representation across data centers, right? So you have
exactly.
So that if one data center goes down, then somebody else from the second one can be primary, right? Or something.
Correct. Exactly.
Yeah, so this is, I think we are moving at the end now. So this is how shard will look like as a pattern that we have. This router would be, as a part of the request, would be going from client, serve the purpose of client to the shard. And this configurations, config servers would be stored the metadata of the settings of this shards cluster, maybe like which shard has what kind of a data. So these configurations would be there, can be set over there. And and each shard contains a subset of sharded data, which can be deployed as a one replica set. There is a Mongoose, which is one which act as a query router, which will be provide an interface between the client application and the sharded cluster. So which reduce latencies to query the data. So at this note, we are at the end of our presentation. So, and please jump on and please share if something has been missed and some more things which are important to know in this area.
So if the client needs to write data to, more than one shard, then who would handle that? Does the client need to know that, okay, I have to write you this shard first, and then I have to write you another shard? Or like the client just send a set data, right? And somewhere it have to say, okay, this data have to go to shard 1, the other one have to go to shard 2.
I don't think client would don't know this. Like it doesn't the headache of client to know which shard it should go in. It's just like how we are providing we are creating our backend data that
right.
Yeah, I think the router is doing that.
Router is solving that.
Goes to router redirects based on the key which shard it has to go to.
Yes. So let's say, suppose I store, I want to update my name and my address, and then name is on, you know, one shard, and address is on another shard, you know.
It will not be possible because so if you in a document, how this is document is like a name, and all the information of that particular user would be in one document. So that document will be only in one shard. That will not be distributed in different. So we are distributing the documents over here in the shards. We should not be distributing the particular person's information in different shards. Is that correct? If I am not.
Yeah, I think that's my understanding. The purpose and the main design of the MongoDB is based on that. All the data correspond to one document, is one partition.
Yeah,
and that's and you don't need to go to multiple partitions just for one document.
Yeah. So, for example, if, as you mentioned, Lan, that you want to update the address of your, then it would automatically. So it would just make just know your document ID, and based on the configurations we have said that which shard would have that information of that particular document, it would go to that shard and it would update that. So, and yeah, but if we query like this, that we need to update for example, we need to update some people information who has status as for example, immigrants, then we don't know that would be in one particular shard. That can be status, can be but those information can be on multiple shards. So that, yeah, then it would go to all the shards to update that information.
So back to my use case, right? I'm the client. I need to update my name and my address, and I want to update them. Either I update them both or none. So first I have to go to update my name. If it's success, then I go to update the address for the shard, right? And if so that is not success, then I have to roll back somehow.
So MongoDB would be like one. It could do two things at one time. So if you want to update name and address at one time, it could do that. And if one query fails, if for example, if it is not able to update the, for example, you have a document in a database that you have your information, but you don't have a middle name in that document. You have first name, last name, and address. But later on, you want to update to your document information with adding a middle name and adding a new address information as well. You can do that. So it would be appending. So as mentioned, that it would be, as we know that the NoSQL would add the new fields on a fly. So if, for example, if sorry. So as we have, as I mentioned, we have first name and last name and address of you. And later on you decide to update your document with the middle name, add the middle name and new address in your addresses field, then it would just add that middle name. And if your document is like you just need to add one single address, like it should be like you don't have an array of addresses, it is just one single category that your address is like some kind of a string, it's not object, then it would update the address information. It would just replace whatever the address with the new data you have provided. It would update that, and it would update two things at the same time. Is that answer your question?
Yeah, that's fine.
Okay. And anyone has any information, or anyone wants to share any thoughts on this? Okay, then I think we can get back to Santosh. Are you speaking anything because we're not able to hear you?
No, I'm saying, yeah, it was a really good, lot of information. Yeah, and yeah, thanks for this. Are you going to share this presentation?
I can, yeah.
Yeah, please, yeah, do that.
Yeah,
It's more helpful.
definitely.
I will stop the recording and then we can check.
Yeah, thank you.